All right. So let f of x be this function, and I want to answer two questions. Where is f continuous? And at each value of x where f is discontinuous, can I redefine the function to make it continuous? Okay. So part A. So remember that continuity, now we are being more precise with the mathematical terminology, but continuity is essentially something you should already be familiar with, right? It's the direct substitution property, essentially. So if I ask you, where is this function continuous? That is the same thing as asking, where does f have the direct substitution property, right? How can you calculate the limit of f by simply plugging in the number? So can we answer that question? If I wanted to calculate the limit of this function at some number, let's say I wanted the limit of f of x as x approaches 4, or I wanted the limit as x approaches 2, or limit as x approaches, say, 3, or whatever. It doesn't really matter what the number is. But can you tell me in which cases would I just plug in the number and that's it, and I can forget about it, that's the limit. So when am I able, for which x values can I actually do that for this particular function? All real numbers except x equals 3. Exactly. We learned last week if I have a rational function, a ratio of two polynomials, you can always just plug in the number to calculate a limit, except where the denominator is 0. So for all x except x equals 3. Okay, so we can say f is continuous on the set minus infinity to 3 union 3 to infinity, right? When I ask you where something is continuous, I always mean a set of x values. Can you tell me, so those three conditions, just to put them on the screen just temporarily, the three conditions for continuity, f of c exists, the limit exists, and the limit is equal to the function value. Now that we've determined that this function is discontinuous, which of those properties does this function violate at x equals 3? So undefined, so first. Okay, so does not satisfy um, first property of continuity. And then, like I said, once you don't satisfy the first property, you automatically don't satisfy the third property. So I'll say first and third properties. What about the second property? Well, we actually haven't done that yet. We actually do have to figure that out. So f of x does not satisfy first and third property. The second property asks about the limit as x approaches 3. So for that, we actually haven't even done that calculation yet. But the answer will be yes, it actually does satisfy the second property. It's just a matter of this function not being defined. Okay, so let's make it very clear. So right now, f of 3 is undefined. So what is this question asking? At each value of x where f is discontinuous, can I redefine the value of f so that f is continuous there? So it's asking us, can we choose a value for f of 3 to make f continuous at x equals 3? How would you go about finding that value? Can I just choose any old value? How would I go about finding the value that would make f continuous? Factor the numerator. Why are you factoring the numerator? So I think you're kind of a half step ahead. So can you explain why you're factoring the numerator? Colleen, we're looking for values close to x equals 3, so we find the limit. So to cancel the x minus 3. So in other words, John, you're finding the limit as x approaches 3, right? So in other words, if I want this function to be continuous, it has to satisfy all three of those properties from earlier, right? So in particular, it has to satisfy that third property, right? So we would need f to satisfy property that limit as x approaches 3 of this function is equal to f of 3. So keep in mind what this is telling us. If I want the function to be continuous, it must satisfy this equation. Now, f of 3 right now is undefined. So in other words, this equation tells us exactly what f of 3 has to be to make the function continuous. Right? It says, okay, f of 3 has to be whatever this number is on the left-hand side, if it exists. So the left-hand side tells us what the new value of f of 3 should be. Okay, so let's compute that limit. Okay, so like some people said in the chat, we factor the numerator. So let's see, we get here x plus 4, x minus 3 over x minus 3. We cancel out the x minus 3's. We're left with x plus 4, and now we can directly substitute. Whoops, it's x approaches 3 of x plus 4. So now I directly substitute, and I get 7. Okay, so that tells us if I want to make the function continuous, I must have f of 3 equals 7, right? If I have f of 3 equals anything else, then this condition for continuity would not be satisfied. So we must put f of 3 equal to 7. All right, what's going on graphically in this case? Here's 3, 7. All right, so this is a function. Oh, sorry, this is a graph of the original function. Y equals f of x, and I'll say before redefining f of 3. All right, so this is a graph of the original function. And the question we asked was, can I redefine the function at 3 to make the function continuous? So this function essentially, well, sure, as long as you just essentially fill in that hole in the graph, now the function is continuous. So that's what the question is actually asking. Is there a hole that you can just kind of fill in the graph to make the function continuous, and how should you do that? What value should you give, right? So if we define f of 3 equals 7, then f becomes continuous. Right, we're going to see that this is not always possible, right? The main thing that made this possible was that this limit existed in the first place, right? The limit as x approaches 3 existed. If that limit did not exist, then there would have been no possible way to fill in any hole in the graph to make this function continuous. Any questions about this problem?